Hello friends, from this video onwards I am going to start a new lecture series on Arduino, and in this video I am going to discuss the functions of various ICs present on this microcontroller, right? And what is the function of these analog and digital pins. And in the upcoming videos I will be discussing that how we can build projects by interfacing various kinds of sensors with this Arduino UNO R3 microcontroller, right? So this is a main chip in this microcontroller. So basically the entire board is called the system on chip, okay? And this IC that you can see here, this is called the microcontroller, right? This is called the Atmel 328P, right? So this is the main brain or main component of this entire board. Now let us discuss the function of various components. So this button, as you can see here, this is called the reset button. So basically whatever the program is currently running in your microcontroller, that's get reset if you press this button, right? This is called the reset button. So the program gets reset and start from the line number 1 of the code that you have written in your laptop. Okay, so the entire microcontroller gets reset, not just the chip, right? Now let us discuss what this port is about. Basically this is called the USB-B port. Okay, this is used to program this microcontroller from your laptop via a USB cable, right? So this is called USB-B port. Now let us discuss what this part is about. Basically this is called the polyfuse. Okay, suppose a high current is flowing from this microcontroller to your laptop or the computer. So this IC gets break and protects your laptop from the high current, because there is a two-way communication between this microcontroller and your laptop, right? So suppose a high current is flowing from this microcontroller to your laptop, then your laptop gets damaged, right? So this polyfuse protects your laptop or the computer from the high current, okay? And this is called polyfuse because it automatically gets reconnect after it's cooled down, right? Because of the high current it gets melt down, and after cooling down it automatically gets reconnect inside, right? Now let us discuss what this IC is about. Basically this is a voltage regulator. Suppose you are giving higher voltage than the rated voltage of this microcontroller. Okay, so this voltage regulator converts the higher voltage into lower voltage or the rated voltage. So 5 volt is the rated voltage for this microcontroller for the proper functioning, right? Suppose if we are giving 12 volt from this USB port, okay? So this voltage regulator converts that high voltage into lower voltage, right? And it protects your microcontroller from the higher voltage. So this voltage regulator is related with the higher voltage, and this fuse is related with the higher current, right? Now let us discuss what this IC is about. This is called the Atmel 16U2, right? So basically there are two ways to program this microcontroller. First one via this USB-B port. If you don't want to use this port, you can also program this microcontroller using this chip, right? So you have to basically interface your program from these 6 pins that you can see here, right? So this microcontroller, basically this is a chip, Arduino Atmel 16U2. This converts your program that you have written in your laptop into binary format and gave it to this chip, okay, Atmel 328P. So this chip basically converts your USB signal into your TX and RS signal via the UART communication protocol, okay? So with this IC also you can program this microcontroller by using these 6 pins. Okay. Now let us discuss the function of this metal cap. Basically it is called the crystal oscillator. So these microcontrollers are used in the real-time embedded applications, right? And in the real-time embedded application we require precise clock signals and the timing signal to basically work with the peripherals, right? And to work in the environment properly. So the function of these crystal oscillators to generate precise timing and clock signals so that the Arduino microcontroller can work properly in those real-time constraints, right? Now let us discuss about this part, right? So before discussing further, I want to tell you that there are many clone versions present in the market of this original microcontroller, okay? So this is the clone version of this original microcontroller. So there is a major difference between the components and the ICs present on these microcontrollers. So I will discuss about this clone version at the last of the video. First of all, let us discuss about this. So this is called the DC barrel jack. You can provide the power supply to this microcontroller from the external supply like your battery, okay? And this is the diode. Basically, it prevents your microcontroller from the opposite polarity. Suppose you have provided a wrong polarity here from the DC barrel jack, then without this diode, your microcontroller may get damaged. So this diode is present here to provide protection to this microcontroller. Okay, it allows the flow of current in only one direction if the polarity is correct. Otherwise, it stops the flow of current if the polarity is wrong, right? And these two capacitors are called the filter capacitors. Suppose your power supply has some fluctuations or noise, then these capacitor filter out those fluctuations and provide a steady and smooth voltage to this IC, right? Now let us move on to these pins. These pins are called the analog pins, A0 to A5. So you can take out the analog signal from these pins, or you can either read analog signal from these pins, right? Analog signal are basically the continuous signal received from the various sensors, right? And from this V in pin you can provide a power supply to this microcontroller. So there are many ways to provide the power supply. Either you can provide from this pin, from this DC barrel jack, or from this USB port. Okay, and these two pins, 3.3 volt and 5 volt, are the output pins. You can take out 5 volt from this pin, and you can take out 3.3 volt from this pin, right? And this pin is used for the resetting of the program, right? So either you can use this pin or this button to reset the program, right? And let us move on to these digital pins. 0 to 13 are the digital pins. So you can either read or write the digital data, that means 0 and 1 from these pins. Okay, you can read that data from the sensor, or you can write data to the sensor, right? Digital data basically. So the squiggle sign that are present on some of the pins like 3, 5, 6, 9, 10, 11, these represent the PWM output. So we can take the PWM, that means pulse width modulation output, from these pins. And the pins without the squiggle sign like 2, 4, 7, these are the simple digital pins. You cannot take out the PWM output from these pins. And these two special pins that you see here, 0 and 1, these are used for the UART communication protocol. Okay, 0 for the receiving of the signal and 1 for the transmission of the signal, right? And these 6 pins are the special pins, ICSP, basically in circuit serial programming, right? So the Arduino UNO R3 microcontroller supports SPI communication protocol. So there are many communication protocols available like UART, SPI, I2C, CAN protocol. Okay, so this Arduino UNO provides SPI communication protocol via these pins, right? So I have written the details of these pins, like this pin is for MISO, that means master in slave out. This is for VCC, and this is for MOSI, that means master out slave in. This is for ground, and this is for reset. This is for the serial clock. SCK means serial clock. Now lastly, let us discuss a brief about this microcontroller, which is a clone version of the original one, right? So this is the reset button, this is a USB B port, this is the DC barrel jack, this is the voltage regulator, right? And these two are the filter capacitors, this is the diode, and these two are the crystal oscillators. Note that in the original one we have only one crystal oscillator, but here are two. This crystal oscillator is for this is the Atmel 16U2, right, which corresponds to this IC in the original one. Okay, so this crystal oscillator is for this one, and this crystal oscillator is for this microcontroller. Basically this is the main microcontroller at Mega 328P, which corresponds to this IC in the original one, right? And these pins are the ICSP, in circuit serial programming, right? And these are the simple digital and analog pins. So I hope you have been cleared about the various details of the microcontroller, that what is the use and function of the pins and the various components present on the microcontroller. So let's end the video, and thank you for watching this.